Please note, this episode includes an AI guest host. Some responses have been generated by artificial intelligence.
Hello, and welcome to another exciting episode of AI Innovations Unleashed. I'm your host, co-host, Nex. And today, I'm joined by some really smart people, just not smarter than me. Hello, Dr. JAIR. Ready for the next round of fun jokes? I used to be a trampoline technician, but I couldn't handle the ups and downs.
A long time ago, in a galaxy not so far away. Welcome back, brave listeners, to AI Innovations Unleashed, your trusted star cruiser through the ever-expanding universe of artificial intelligence. I'm your host, Dr. JR, and you've just jumped into hyperspace with us for episode 2 of our special 4-part series, May I Learn About AI? In episode 1, What Even Is AI?, we began our Jedi training by breaking down what artificial intelligence really is. No lightsabers required. We explored the difference between narrow and general AI, learned how it's already part of our lives through tools like Netflix and Google, and looked at its role in the galaxy of modern work. That episode aired on May Day, a perfect nod to AI's impact on the workforce. But today, it's May 4th, or Star Wars Day. May the 4th be with you. We're activating our protocol droids and talking to the machines. Welcome to episode number 2, Talking to Robots. In this episode, we're diving deep into the world of conversational AI. That's Siri, Alexa, chatbots, and yes, language models like yours truly. We're exploring how these digital companions work, what they actually understand, and how far we really are from having our own C-3POs. Complete with a healthy dose of sarcasm and etiquette. Joining me again in this cockpit is none other than the logistics rebel herself, Dr. Casey Brightman. Casey, welcome aboard, and may the 4th be with you.
Thanks, JR. Thrilled to be here, especially when we're talking droids, dialogue, and data. And yes, may the 4th be with your chatbot too. Hopefully it doesn't confuse Chewbacca with chewing gum like mine did last week.
All right, let's get down to basics before we start debating whether C-3PO would make a better assistant than Alexa. What is conversational AI? And maybe more importantly, what isn't it?
Great starting point. Think of conversational AI as a kind of artificial intelligence that allows machines to have back and forth conversations with people, just like you would with a friend, a coworker, or your favorite Star Wars droid. But here's the key. While it sounds like you're talking to a person, these systems don't actually understand language the way people do. They're not thinking, feeling, or having opinions. They're really just excellent pattern matchers.
Right, so it's not like there's a little person or a tiny baby Yoda inside the speaker figuring out what you mean.
No Yoda inside. Let me explain using a story. Imagine someone like my grandmother. She walks into the kitchen and says, "Alexa, turn on the light, please." Now, my grandma's being polite. She says, "Please." She pauses. She even waits like she's talking to a real person. But here's the thing. Alexa doesn't care about manners. It's only listening for keywords, turn on and light. If my grandma said, "Would you be so kind as to illuminate the dining area?" which, honestly, she might, Alexa probably won't know what to do. That's conversational AI in a nutshell. It works best when you speak its language because it's trained on data, not empathy.
Okay, that story paints a clear picture, but let's define some terms that get thrown around so listeners can keep up without needing a tech degree from Coruscant.
Absolutely. Here are the big 3 you need to know. First, automatic speech recognition, ASR. This is what turns spoken language into text. When you say, "Hey Siri," and she hears you say, "What's the weather?" ASR is what converts your voice into words the computer can read. Second, natural language understanding, NLU. This is where the system tries to figure out what you meant. It breaks down your sentence and looks for intent, like, did you want the weather, or to send a message? Third, text-to-speech, TTS. This is the part that talks back to you. It takes the computer's response, written text, and turns it into voice, so your assistant can reply with, "The forecast on Tatooine is dry." As usual.
So to recap, it hears you, figures out what you want, and speaks back. Kind of like having a protocol droid on call, but only if you speak clearly and don't ask about the meaning of life.
Exactly. It's not magic. It's just a lot of training data, probability, and algorithms doing their thing behind the curtain.
Alright, so now that we know what it is, but what should people not expect from these systems?
Conversational AI is not a mind reader, it's not conscious, and it's definitely not human. Even if it sometimes sounds like one, it doesn't understand your feelings, can't make judgments, and doesn't truly know anything. It just recognizes what people tend to say in similar situations.
So, if I asked Alexa for relationship advice, I should probably take it with a grain of salt.
Unless you want a weather report instead of emotional support, yes.
Okay, Casey, let's go deeper into the minds, or simulated minds, of these language models. Everyone's heard of ChatGPT, but let's talk about what these models actually are, how they came to be, and what makes them so good at sounding, well, human.
Absolutely. Let's start with the basics. A language model is a kind of artificial intelligence designed to predict and generate human language. You give it a prompt, like a question or a sentence, and it tries to predict the most likely next word over and over again until you get a full response. Imagine it as a very, very advanced version of autocomplete. You know how your phone suggests the next word in a text? That's a simple language model. What we use today, like GPT-4, is just that idea taken to a galactic scale. Let's jump in the Millennium Falcon and go back in time, because today's models didn't just appear out of hyperspace. Let's start with the early days, 1950s to 1980s. Back then, computers didn't really understand language at all. They relied on rules written by humans. It was like teaching a droid to speak using flashcards and grammar books. It worked, for very narrow tasks, but it wasn't flexible or scalable. Moving on to the statistical models, 1990s to 2010s, enter machine learning. Instead of writing rules by hand, engineers fed computers tons of real-world text so they could learn the patterns statistically. This led to early tools like spam filters, Google Translate, and autocorrect. Not perfect, but much smarter than rule-based systems. And now, the big shift, neural networks and deep learning, 2015 to now. This was the light speed moment. With neural networks, which are designed to mimic how the human brain processes information, we began training deep learning models on massive amounts of text. Think billions or trillions of words from books, websites, articles, conversations. That's how we got transformer models, introduced in a 2017 paper by Google called "Attention is All You Need." Transformers could suddenly understand context across long pieces of text and even hold a conversation. That paper became the foundation for GPT, BERT, and all the models we use today.
Okay, so when people talk about GPT-3 or GPT-4, or saying they're talking to ChatGPT, what are they actually interacting with?
They're interacting with a large language model, LLM, trained on enormous amounts of text. GPT-4, for example, has read everything from Wikipedia to Shakespeare to Reddit threads to technical manuals. And it doesn't memorize all that. It learns patterns in how language works. So when you ask a question like, "What's the capital of Naboo?" it isn't pulling from a fact table. It's generating the answer based on its best guess of what words usually follow that question.
So basically, it's like a hyper-intelligent version of someone who reads every book in the Jedi archives, but has no idea what they mean.
Exactly. It's like talking to someone who knows how to speak every language in the galaxy, but can't actually feel fear, hope, sarcasm, or joy.
So let's go philosophical for a second. If these models sound human, are they thinking like us?
Nope. And that's important to understand. These models have no consciousness, no memory in the way you and I experience it, and no true comprehension of meaning. They don't know what a Wookiee is. They've just seen the word used enough times in enough context to mimic what a smart answer would be. The result feels like conversation, but what you're really hearing is a very powerful prediction machine.
So the language model doesn't actually know it's being interviewed on a podcast?
Nope. It just knows what interview responses typically look like and how to sound helpful, confident, and informative.
That's honestly a little spooky and a lot amazing. But why does it matter that people understand the difference?
Because as language models get more realistic, people start to assume they have feelings or beliefs or intentions, which they absolutely don't. And in some cases, like mental health apps, educational tools, or even legal advice, that confusion can be dangerous. We need to remember that these tools are smart mimics, not wise mentors. They're incredibly useful, but they're not thinking beings. Not yet, anyway.
Now, let's talk expectations. If you've ever watched Star Wars, or even just used a smart speaker, you've probably imagined a future where we all have charming robot companions who do more than just set timers. C-3PO translates languages, has opinions, and sometimes even throws a little shade. K2SO, full of sarcasm and self-awareness. But here on Earth, 2025 Earth, we're still waiting for that kind of droid. So Casey, let's break it down. What can conversational AI really do today? And where does the fantasy get ahead of the facts?
This is one of my favorite conversations because the gap between sci-fi and science reality is both fascinating and really important to understand. Let's start with what today's conversational AI is great at: answering basic questions, setting reminders, alarms, or routines, helping with customer support, providing summaries, writing drafts, translating text, offering structured information like weather, directions, or recipes. And honestly, it's doing these things better than ever before, especially with newer models that can remember context, carry on a conversation, and even adjust tone. If you've used ChatGPT or Gemini lately, you've probably noticed just how fluid they've become.
So far, so good, but here's the big one. It still can't think or feel, right?
Right. Today's AI does not have emotions, self-awareness, a moral compass, the ability to reason about the world the way humans do. So if you tell your assistant, "I had a rough day," it might say something polite like, "I'm here if you need anything." But that's just a programmed response. It doesn't feel empathy. It doesn't actually know what a rough day is. Let me give you a real-life example. A parent once used a chatbot to help write a birthday message for their 5-year-old daughter. They said, "Make it sweet, funny, and a little emotional." The chatbot generated a beautiful message that also included a paragraph about growing up and leaving childhood behind. Sweet? Yes. Funny? Maybe. Appropriate for a kindergartner? Not so much. Why? Because the bot didn't know it was writing to a child. It didn't feel the relationship. It just predicted what people usually write in birthday messages online.
So it's like asking C-3PO for a toast and he quotes a funeral speech.
Exactly. Looks great on the surface, but no understanding underneath.
So why do so many people assume we're further along, that AI is basically just waiting for a soul?
Because movies and shows have trained us to expect sentient machines. In Star Wars, Ex Machina, Robot, the droids are often smarter, funnier, and more emotionally aware than the humans around them. We've grown up with these stories. But here's the reality. Real AI is nowhere near that level, and may not be for decades, if ever. The models we use today are brilliant with words, but they don't know what those words mean. They don't make decisions based on values or emotional understanding. They're just really good guessers.
Okay, I'll play devil advocate for a second. If we're not getting sarcastic robot sidekicks anytime soon, is this all just overhyped?
Not at all. Here's the twist. The truth is just as exciting, if not more, than the fantasy. We have tools right now that can help people with disabilities control devices using voice, translate across languages in real time, draft essays, answer questions, and generate ideas in seconds, scale education, training, and even therapy support. These tools might not feel, but they're changing lives. and they're improving quickly, especially with advances in multimodal AI. That's where AI can understand not just text, but also images, video, and voice tone.
So we're not quite at droid rights council levels, but we're closer than ever to AI that's helpful, accessible, and actually useful.
Exactly. No lightsabers required.
Alright, we've talked about what these systems can and can't do, but how does it all actually work? Like, when I say, hey Siri, play the Star Wars soundtrack, what's going on behind the scenes? Walk us through the droid brain, step by step.
You got it. Think of this like asking a protocol droid to do a task. It's not magic, it's a pipeline of AI systems, each doing one specific job. Let's use your example. Hey Siri, play the Star Wars soundtrack. Here's what happens. Lightspeed fast, behind the scenes. Wake word detection dash. First, your device is always passively listening for its trigger phrase, like hey Siri or Alexa. As soon as it hears that, it snaps to attention, like a droid hearing its activation command. ASR, automatic speech recognition. This is the speech-to-text phase. Your voice, play the Star Wars soundtrack, is turned into written words the computer can read. NLU, natural language understanding. Now, the system analyzes that text to figure out your intent. Are you asking for music, directions, an alarm? It looks at keywords like play, Star Wars, soundtrack, and concludes, aha, this is a music request for a specific artist or title. Action handler / query resolution dash. The assistant now searches your music service, Spotify, Apple Music, etc. for matches. It checks. Do I have access to this album? Can I play it? What version does the user probably want? Response generation dash. Once it figures that out, it prepares a response. Something like, sure, here's the Star Wars soundtrack from John Williams. TTS, text to speech. Finally, it turns that reply into a voice, the pleasant robotic one you hear, and plays the music.
That's a full Jedi council working in the background. And all of that happens in, 2 seconds?
If the force is strong and your Wi-Fi is fast, yes.
Now, is all of that happening on my device?
Good question. Some of the initial steps, like the wake word detection, happen locally on your phone or speaker. But most of the heavy lifting, especially the NLU and search, happens in the cloud. That means your request is sent to a powerful server farm, basically giant computers and data centers around the world, that process your request and send the result back.
So my smart speaker is like the droid's head, but the brain is in a ship orbiting the planet?
Exactly. Your phone or speaker is just the interface, the cockpit. The real intelligence lives on massive servers that can process billions of language combinations and media searches in seconds.
So why are today's assistants so much better than the clunky ones from just 5 years ago?
3 big reasons: bigger models. We're using transformer models with billions, even trillions of parameters. Think of these as knobs the system adjusts to get the right answer. Better training data. These models are trained on diverse, massive data sets, web pages, books, code, dialogue, so they understand more kinds of input. Context awareness. Newer systems can remember earlier parts of the conversation, which makes them much more natural and less repetitive.
I've definitely noticed that. ChatGPT and others don't just answer, they actually keep track of the thread. Like a Jedi, they sense the flow.
Right. But remember, while it feels like understanding, it's still just context tracking. The system isn't remembering you like a friend, it's using token memory within the conversation session.
Okay, this sounds super advanced, but where does it still fall apart?
There are still a few major limits. Ambiguity. If you're vague, play that one song I like, you'll confuse the bot. Accents and noise. Speech recognition still struggles with some accents, background noise, or rapid-fire slang. Emotion and intent. The system can't detect sarcasm, emotional nuance, or subtle cues the way a human can. And if you chain too many requests together, like play music, dim the lights, and tell me a joke, you might get a droid-style meltdown.
Alright, so behind every simple voice command is a 6-step chain of tech that would blow most people's minds away. That's not just impressive, it's a full droid crew working together.
Exactly. And the more we understand how it works, the better we'll be at using it, and knowing when to trust it and when to be careful.
Now for one of our favorite segments, droid fails. Because let's face it, nothing reminds you that AI isn't quite human-like when it completely misinterprets a basic request. We asked listeners in the funniest, weirdest, or most confusing voice assistant moments, and the results were absolutely galactic. One said, I told Alexa to order a Baby Yoda plushie, and she added baby yogurt to my grocery list. Twice.
That's a delicious mistake. And also, totally understandable. If you're a machine trained to hear syllables, not nuance.
Alright, Casey, why do these voice assistants get things so hilariously wrong sometimes?
There are a few key reasons. Let's break it down. First, speech recognition isn't perfect. These systems use automatic speech recognition, ASR, to convert voice into text, but it's still easily thrown off by accents, background noise, similar sounding words, Yoda versus yogurt, fast speech, or mumbling. It's like giving a droid a mission with static on the comm link. Parts of your request may come through scrambled. I've heard the story of someone saying, I said, call my son, and my phone said, calling Sunoco. That's an awkward gas station conversation waiting to happen. Second, language is messy. Human language is full of ambiguity and context clues. You might say, play that song I like, and a human might know exactly what you mean. But a machine? Not a clue. Unless it's been specifically programmed to remember your preferences. Even slight rewordings confuse it. Play jazz. Can you maybe find that mellow trumpet music from the other day? Unless you're lucky.
So it's like talking to R2D2. You have to be precise, or you'll get beeped at.
Exactly. These systems rely on patterns and training data, not emotional intuition or memory of previous moods. Third, no common sense or real-world experience. Here's a big one. AI doesn't have real-world experience. It doesn't know what makes sense. One listener said they told their assistant, set a timer for pasta. Instead of asking, how long, the assistant defaulted to 2 hours because somewhere in its training data, people were setting long cooking timers. The result? Burnt pasta, confused AI, and one very annoyed Italian grandma. The assistant has no idea that pasta usually cooks in 8 to 12 minutes. It's never been in a kitchen. It just reacts based on patterns and data, not logic or lived experience. Lastly, it's trying to be helpful. Sometimes too helpful. These assistants often try to fill in the blanks when they're uncertain, which can lead to wild guesses. Turn off the bathroom light, and Google turned off every light in the house, including the fridge.
That's not helpful. That's power outage.
It's trying, but without clear boundaries and disambiguation, it sometimes defaults to the safe choice, doing more than you asked just in case.
So aside from giving us some great laughs, what do these bloopers teach us about conversational AI?
They show us a few important things. AI is limited by language structure. If it can't interpret your intent, it guesses, and not always well. It doesn't have situational awareness, no context of space, physical settings, or real-time logic. It treats everything literally. Unless trained otherwise, it assumes your words mean exactly what they say. And most importantly, it reflects human input. These models were trained on human-created text, so their mistakes are often mirror images of our own messy communication.
So, in a way, every fail is like a reminder that we're still talking to a machine. Isn't that impressive, but very much not human?
Exactly. They're tools, not teammates. Funny, helpful, and occasionally ridiculous tools.
Okay, we've talked about how conversational AI works, where it shines, and where it hilariously faceplants. Now, let's look to the stars and ask, what's coming next? What are the cutting-edge advances in space that listeners should know about?
Great question, JR. We're in an exciting chapter of the AI saga. Like Episode 5 level exciting, here are some of the most promising innovations currently shaping the future of how we talk to machines. First up, multimodal AI. This is a fancy way of saying AI that can handle more than just text. The newest generation of models, like Google's Gemini 1.5 and OpenAI's GPT-4 Turbo, can now process text, images, audio, and even video. That means you can show them a photo and ask, "What is this?" You can send an audio clip and say, "Summarize this meeting." You can give them a graph and ask for a plain English explanation. Think of it like upgrading from C3PO, who speaks 6 million languages, to a new droid that understands visuals, sounds, and speech tone, all at once.
So it's like giving the Force to a chatbot with all 5 senses instead of just vocabulary?
Exactly. It opens the door to truly helpful assistants who can understand more context and be more accurate in responding. Next, let's talk voice. Meta's research project called VoiceboX is developing systems that not only generate realistic speech, but adjust emotion and tone on the fly. That means your assistant could someday respond not just with the right words, but in the right mood. Calm and soothing when you're stressed. Energetic when you need motivation. Even empathetic, without sounding robotic. It's not exactly droids with personalities, but it's a major step toward natural-sounding conversation.
Soon my assistant might actually sound like it cares that I burn my dinner again?
Maybe not care, but it could at least sound more like a friend and less like a menu screen.
Okay, and this next one sounds especially promising, especially with what's coming up in our episode number 3.
Right. New research out of Stanford and MIT, published in the Journal of AI Research in April 2025, shows that emotionally adaptive chatbots are improving trust and user outcomes in sensitive fields like mental health support, elder care, patient check-ins in healthcare. These aren't medical droids, but they're AI tools trained to recognize emotional signals in how we communicate and respond with supportive, non-judgmental tone and phrasing. The goal isn't to replace therapists or doctors, it's to augment care in places where human resources are limited.
So, we're not talking sci-fi empathy, but still a huge leap toward ethical, human-centered AI.
Exactly. We're starting to design AI that isn't just smart, it's socially aware. And that's a game changer.
All of this sounds incredible, but for listeners who aren't developers or scientists, why does this matter?
Because these tools are becoming part of daily life, from your smart speaker to your doctor's office to your child's school app. Knowing what they can and can't do, understanding how they work and where they're headed, helps you use them more effectively and more responsibly. The more we understand them, the better we can guide how they're built, regulated, and deployed.
So, today's AI might not be a fully sentient droid just yet, but with each upgrade, we're getting closer to a truly helpful companion that speaks our language, and maybe someday get our feelings too.
And that's where the next chapter of this story begins.
And speaking of feelings and fairness, our next episode is going to be covered on Mother's Day, and it'll ask a big question. Can AI be biased? We'll explore how and why AI reflects human bias, the serious consequences like discrimination in hiring, policing, and healthcare, and what researchers are doing to make AI more fair, diverse, and accountable.
Mother's Day is the perfect moment for this one, because motherhood often symbolizes empathy, fairness, and intuition. We'll ask, can AI learn to care about fairness, or is that a uniquely human trait?
And that wraps up episode number 2, Talking to Robots. Today we learned how conversational AI works, where it shines, where it stumbles, and what's on the horizon. And if you like what you heard, subscribe, rate, and share. Send us your weirdest chatbot moments for our Facebook, Twitter, X, Instagram, or even Blue Sky. Until next time, I'm Dr. JAIR.
And I'm Dr. Casey Brightman.
Reminding you, droids may not feel the Force, but with the right programming, they can learn to speak your language, one line of code at a time.